Welcome to our second video in which we use the trigonometric ratios from the unit circle to solve equations in a finite interval by using the unit circle. Basically what we're doing is using the unit circle as a kind of a paper calculator. So let's look at this example. Don't be confused by the equation. We have x here. We also have an x-axis. If we think of it as cosine theta is minus root 2 over 2, and if we think of the domain as this, it will give us a start. Okay, so cosine is negative. We can see from the unit circle one answer to the equation immediately right here, because the cosine is the x-coordinate and it's negative root 2 over 2. Now, by symmetry of the unit circle, we can see with a vertical line, there's another solution right here, 225. So we already have two answers. X is 135 degrees or 225 degrees. But look at the domain of this question. It's between minus 360 and 360. So these two solutions we've done in the positive sense, 135 degrees and 225 degrees. But we can also reach those destinations in the negative sense. So that gives us minus 225 degrees. And it also gives us minus 135 degrees. And those are the only solutions in that domain. And we must write them in radians because that's what the question asked for. And in radians, it comes down to plus or minus 3 pi over 4, plus or minus 5 pi over 4. Easily done with the unit circle. Let's see another one. Sine 2x is root 2 over 2. Okay, let's write that as sine 2 theta equals root 2 over 2. So, root 2 over 2 is positive. We can see one solution here where the y-coordinate is root 2 over 2. That's 45 degrees. Now, because sine is the y-coordinate, this time we can draw a horizontal line and we see another solution, 135 degrees. So we've already got two solutions. Now, in this domain, I should have said that's 2x. We're solving for 2x, or rather 2 theta. Now, if we take 45 and then add another 360 degrees, we get to the same destination. And that will give us 405 degrees. And if we take 135 and then add another 360 degrees, we get to the same destination. That gives us 495. Why am I doing this? Because we're trying to find theta and we must divide by 2. When we do that, we get 22.5 degrees, 67.5 degrees, 202.5 degrees, or 247.5 degrees as our possible solutions. If we didn't add on the extra 360, notice these numbers are outside the domain, but when we divide by 2, it gives us 2 answers inside the domain. Let's do another one. We've actually seen the answer to this on the previous video. Tan x is root 3. Well, we know that the value of tan gives the gradient of the segment. And here was one example where the gradient of the segment is root 3. And here is another one, 240. And again, if I add another 360 onto 60 degrees, I get to the same destination. So that gives me another solution of 420 degrees. Notice the domain this time is 720. And if I add another 360 onto 240 degrees, I get to the same destination. That gives me the final solution of 600 degrees. Our final equation looks much more complicated. It's a quadratic. If you look at it closely, if I use t instead of sine theta, what I have is 2t squared plus t minus 1 equals 0. Now that factorizes to 2t minus 1 t plus 1 equals 0. And our domain is not 360. In effect, this means we're solving 2t equals 1, so t is a half. That means sine theta is a half. And also, t equals minus 1, that means sine theta is minus 1. So to take the first equation, sine theta is a half. We can see from the unit circle right away. Here's an answer here, 30 degrees, for which sine theta is a half. And with the vertical line, horizontal line, we can see by symmetry another one, 150 degrees, that also has sine a half. So we have theta is 30 degrees, or 150 degrees. And those are the only ones in the domain of not 360. Sine theta is minus 1. That takes us to the only point on the circle with y coordinate minus 1. It's 270. And these are the only solutions in the domain specified. Okay, well, in our next video, we will see how to use the double angle identities in solving trig equations.